the force and the displacement, and then we can calculate the work, right? Using variable force, using the constant force. So that part we understood, right? Whenever they want you to calculate work done, always remember to try to calculate the force, right? This is one method, or there is another method in which you can also calculate the work done, and that is by change in kinetic energy, right? So you are applying some force, and you don't know about the force, but you know that initial speed was, let's say, something, the final speed was something. So from the change of the velocities, you can also calculate the work done, right? So these things we understood in the last class, and we did a couple of questions, right? And we also saw the impact of frictional force that we also saw. So now, then I told you guys that we will talk about vertical circle, right? What is vertical circle? So, it's my, yeah. So we have, let's say this is the mass. Yeah. This is the mass which is hanging with this thread. So if I give this thread some initial velocity, right? So it will come back again, right? And I give this initial velocity such that enough initial velocity to that it rotates and sorry, so it rotates and come back. It makes a full circle, right? And you guys have seen this thread, and then we rotate in such a way that it makes a full circle and it rotates again, right? So that would be called a vertical circle. Circle which is vertically, so mass which is vertically moving and making a circle, right? So to do that, first we have to do what? We have to provide enough initial velocity so that it rotates and it makes a full circle, right? If we don't provide enough velocity, then it will go here, and then due to what force it will fall down? Due to what force it will fall down? Yes. What force we have to overcome to make it a full circle? Yes. We are providing this initial velocity, right? So what force we have to overcome so that this makes a full circle?
Gravity.
Gravity, absolutely right. So we have to overcome the gravity so that it makes a full circle. So that is the idea about this vertical circle that we have to understand. And to have a complete circle, the minimum velocity we should provide so that it makes a full circle. So that is we are going to calculate, right? Yeah. So now let us understand about. Right. So you guys have rotated some stone, and yeah, so hanging those stone with some thread. And did you guys rotated that stone at some point? Did you guys do that experiment? Never.
No, sir.
Okay, yeah. Okay, all those experiments have some physical meanings, right? All those carry some physics behind. Yeah. So then we have to understand about vertical circle, right? So let's say first there are we will calculate three positions that we have done also in the NCRT part. But let us understand that again. So we have this mass, right? Initially, we are providing some velocity. Let's say, yeah, we'll call that some name, but let me make a proper circle, right? we have some center of this circle, and this mass is hanging with this circle. This is the path that I have made, right? This is the path, not some ring or something like that. This is the path that I have. So this position is, let's say, this is the reference that I'm taking, right? This point is A, and I am providing some initial velocity VA, right? I am providing some initial velocity VA, and then it reaches here, right? The radius of this thing is, let's say, R or whatever R, and this goes in here, right? So now its velocity has become, velocity is always tangential, right? So this is the velocity, which is VB. This is point B, right? And then it reaches, so if it is making a full circle, then it is reaching here, right? So it is reaching here. And this point, we will call it as C point, right? And what are the things we have to remember? The two concepts that we will apply in here is, first is free body diagrams. That is very crucial. And the second thing that we will apply is energy conservation theory or energy conservation. Right? So these two concepts we have to apply. And the goal is what, guys? Goal is that we have to calculate the minimum velocity with which we have to throw this, we have to push this stone so that it makes a full circle. So we have to find out VA, we have to find out VP, we have to find out VC. These are the three goals that we have. And these are the two concepts that we are going to use. Right. So first, let us talk about this thing is moving in circle, right? So then, what kind of acceleration would be there towards the center? Yes. Let me write the third one. So what kind of acceleration would be there towards center if this is moving in circle? If you have a circular motion, so what kind of force, what kind of acceleration work towards the center? Hmm. So centripetal force or acceleration. Okay, so centripetal force will act towards the center. So one force which is acting, that is centripetal force. This is a thread, right? I should not write this C. So how should I write centripetal? I will write okay. So one force is acting towards its center, right? Other force would be due to this string. What would be that force? Due to this thread or string, what would be the other force? Yes, guys. What would be the other force? Other force due to string would be this tension, right? Let me write it as T. Okay. And then there will be another force that would be in the downward direction, that is mg, right? So these are the three forces acting on the mass of this particle, right? And there are no any other forces, right? So there are three forces acting on that object at a point, right? So if we write a free body diagram at A, what would be that? So, so if we write the free body diagram at A, right? We are writing the free body diagram. So what would be that? We have this particle of mass F. One is mg, right? The other one is centripetal force, and then we have this tension, right? Tension due to A. So can you guys tell me what is the principle or what is the law that we are going to apply? Yes, what is the law that we are going to apply? Is this thing at equilibrium? Is this thing at equilibrium? Yes, Siddhika and Rishida, why you guys are so silent today? Is this thing at equilibrium? This thing is not at equilibrium. Why? Because this is moving, right? This is moving with a different velocity, right? So this is not at equilibrium. Acceleration is not zero. So this thing is not equilibrium, then we have to apply the Newton's second law. Newton's second law says that F net is how much? ma, right? And the force is due to this centripetal acceleration, right? So then F net is how much? This is ma centripetal. This is equal to, we have Ta and mg, which would be positive, which would be negative. Yes, guys, which would be positive, which would be negative. Quickly tell me, we don't have that much of time. Okay, so centripetal is in the direction of this Ta, so Ta is positive, then mg is and if I ask you guys, if I ask you guys what is the centripetal acceleration, so that is mva square by r. This is Ta minus m. This is our first equation. Okay, this is our first equation, and let's call it. We have used the free body diagram, right? B part we will use FBT we have used. Now we will use the energy conservation, right? So energy conservation we have to, and we know that the total energy at a point, right? Total energy, let's call it as E, right? That would be kinetic energy plus potential energy. So E is kinetic energy is half mva square, because this is the velocity. What is the potential energy? Potential energy would be mgh, right? H is how much at a point, because this is the reference that we are taking, right? So this height is zero. So there is no potential energy at this point. So then what we will have, then this is zero. So total energy is simply half mva square. Right, this is the second equation. So we have used energy conservation, we have used free body diagram at A. Now second thing we will calculate at B. So at B, what do we have? At B, what do we have? We have this tension at this direction, let's say TB. We have this direction centripetal force, and then in this direction, right? In this direction, we have mg, right? So these are the things that we have. So you see that in this direction, only this centripetal force and this TB will work, right? Because this mg is balanced by this other acceleration, right? So at this point, we don't have any acceleration in this direction, right? We don't have any mg in this direction. So only these two things are working. So what would be the free body diagram at this point? What would be that? So if we calculate F net, right? If we calculate F net, so that would be equal to this tension, right? So F net is mv square vb square by r, and this is equal to t. This is one thing. Now, because we have what? Because at this point we have only TA and we have only this centripetal force. So this tension will act as the centripetal force, right? So then this is first part. Second part is energy conservation. Energy conservation. Right. So what do we know? So at this point, what is the energy conservation? So this is at how much height? What is the height from this reference? What is the height? This is R, right? So potential energy at B would be how much? That would be mgr. So potential energy at B, that is mgr, right? Kinetic energy is how much? That is half mvb square. So then we just put all the values. So total energy would be how much? That would be kinetic energy at B plus potential energy at this is half mvb square plus this is mgr. So this is the total energy that we have. So let's call it fourth equation, and this is the third equation, right? Now at this third point, right? At this third point, the minimum because this is at the vertical position, right? So minimum tension would be zero at this point. So there is no tension in the downward direction, right? So we have at this point, what do we have? We have centripetal force, and this tension at C is we can assume for full circle, right? Minimum velocity for full circle, we can assume that tension is zero. So tension is zero, only mg is there, right? So if we write the free body diagram from here, so that would be how much at C. So if we write a free body diagram, that would be we have FC, right? And this is empty. So F net is mg, right? And this is mvc square by r, and this is mg. This is the right. So this is fifth equation, and this is the other equation would be the energy conservation from energy conservation, right? So from energy conservation, what we can write? We can write that at what position is this thing is. What is the potential energy at this point that you guys can tell? What is the potential energy at C? Hmm? Potential energy at C, how much is that? Yeah, are you guys there? Are you guys listening?
Yes, sir.
So, uh, what would be then it would seem like that you guys are not understanding, right? Please respond. If you have any doubt, please ask, right? So, what would be the potential energy at this point? This is at what height? This is R. This is R. So, this is at 2R height. This is at 2R height.
Yes.
This is at 2R height, and then potential energy would be mg into h. H is 2R. So potential energy at this point would be how much? Potential energy at C, that would be mg into R. So 2 mgr. Kinetic energy, we already know that is half mvc, right? So if we write the total energy is potential energy, total energy is kinetic energy at C plus potential energy at C, right? So this is half mvc square plus 2 mg. So this is the total energy. And from energy conservation, we know that this energy would be equal to this energy, that would be equal to this energy. All these energies are equal, right? So what are the equations that we have? And this is very crucial part, right? If we don't understand this thing, then it's all over. So then we would not be able to understand this vertical circle, right? So now we have six equations, right? We have this one, and let me write all the equations together, right? So first equation is what? First equation is MVA square by R. First equation is MVA square by R TA minus H. So this is the first equation. Second equation is what? Second equation is E equals to half MVA square, right? E equals to half MVA square. Third equation is third one is what? MVB square equals to T MVB square by R, that is TB. And then fourth one is E equals to half MV square. E equals to half MVB square plus MGR. Fifth one is what? Fifth one is mvc square equals to mvc square by r, that is mg. And sixth one is E equals to half mvc square plus 2mg r. Right. So from these relations, you guys can already tell that the speed is maximum at VA. So VA would be maximum, VC would be minimum. How can we tell that? Because we see that at A position, only VA is contributing. There is no potential energy which is contributing. In the second part, we see that this potential energy is also contributing at VB. So this would be smaller. And at C point, we are seeing that the potential energy contribution is maximum. So then this VC would be smaller. So this would be largest, then smaller, then smaller. Now, what was the goal, guys? Goal was to calculate VA, to calculate VB, to calculate VC. And there are another unknowns, right? This is another unknown, this is another unknown. This we don't care, but we care about this total energy, right? This thing is also important. So these things we have to calculate. Now you guys looking at six equations in your hand. Which one among them you can calculate directly? The known quantities are M, G, and R. These are known quantities, right? And these ones are unknowns. So from these known quantities, using the six equations that you have, what is the unknown quantity that you can calculate directly?
Uh, Fifth one.
Fifth one, absolutely right. Good. So fifth, yeah. Did you understand, Siddhika?
Yes, sir.
So we can directly calculate VC from here, right? Good. So this one we can cancel and we can calculate VC square, that is GR. So VC is root GR, right? So this would be the speed at C point. Good. Now we have got VC. Then what we can calculate? So this one is done. This one is done. Now we have one, two, three. These three. So which one we can calculate now? Now you know VC, right?
The sixth one, I think.
Sixth one. Yes, absolutely correct. Good. Yes. Is that correct, Siddhika?
Yes, sir.
So now what you know? You know this VC, right? So you know VC, you know M, you know G, you know R. Then you can calculate what should I use? Let's write it one. Then second, so using this fifth. Now using sixth. So we know that E is half M, VC square is GR, right? So let us directly write. So VC square is GR, and then this is 2mgr. So this would be how much? Mgr by 2 plus 2mgr. So this is 2 to the 4 plus 1, 5 mgr by 2. So this would be the total energy of this system, right? Good. This is the total energy. Now This part is also done, right? We know this thing also. Now these two are remaining. So now can you guys tell me using one of these 1, 2, 3, 4, which one you can calculate?
E.
Yeah, E you already, right? So, oh, A, you said VA. Yeah, now we can also calculate, right, actually. So, oh, yeah, VA we can also calculate, VB we can also calculate, right? So now using the second one, we can calculate VA, right? So using second, right? What is second? E is half M, right? So E is half M square. This is 5 mgr by 2, and this is half mva square. M will cancel, 2 will cancel. So va square is 5gr. So va is root 5gr. So now you guys know that with which velocity we have to throw this object or we have to move this object so that it can at least complete one circle. Right, now you guys know this. So now we can also calculate VB, and what would be VB? So E is half, yeah, fourth one. So using fourth one, E is half mv E square plus mgr. So E is, we know, 5grm by 2 minus mgr, and this is half mv square. So this would be how much? 2 will go there, so there would be 3 mgr by 2 half mv square. This will cancel, this will cancel. So vb square is 3gr. So vb is root 3gr. And as you guys predicted, that the largest value would be A, then this would be VB, and then the last smallest value would be GR, right? So you guys see that this is 5, this is 3, and this is 1. So that is how the speed is decreasing, right? So this was all about the vertical velocity, and then we'll do some question about this one. But you guys please note down this one, right? This was a very important one. That is why I took some time to describe. And then second, then we'll talk about power, and then please note it down, guys. And if you guys have any question, please let me know. Whenever you guys want me to scroll down, please write. Yeah, whenever you guys want me to scroll down, please do it.
So can you scroll down?
Got disconnected.
So can you scroll down? So can you scroll down with the B one?
The B, yeah, this one you missed.
No, 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 the B which the I couldn't. Yeah.
Yes, Siddhika, you got disconnected.
Sorry, sir, I got disconnected.
Yeah,
Could you
so
spell out?
yeah, one moment. Give me one moment, Rishita, right? So you just
Yes, sir.
take the screenshot, Siddhika, right? What
Okay,
part?
sir. Yes, sir.
What part did you miss?
Screenshot.
Yes. What part?
Sorry, sir.
What part
There.
you were
There, sir.
writing? This part you have.
No, no, sir. Done.
This one.
Yes, sir. Here. Yes, sir.
This. Then yeah, please take the screenshot and
Sir, I did that. Could you? Sir, I did this one.
yeah.
Yeah, here.
Then
Okay, sir. Could you scroll up?
yeah, all of you are writing it. So please
Okay, sir. Done. Thank
no,
you.
so no. So Rishita is also writing, so you can
Okay,
also.
despite it's right, she's writing it. Okay, I'll write it too.
So when we have understood this fourth chapter, right, and all the previous ones, then this would become very easy because the fourth chapter was the soul of this. Concentrate on that chapter.
Done, sir.
Done.
1 second, sir.
Okay, then.
One
Oh
second,
yes.
please. Done, sir.
Done, everyone. Okay, so yeah, so now let us do some question and that will clear us some doubt, right? So now we know what do we know that at the minimum point, right? The minimum velocity that we require to make it a full circle, so that is root 5 gr. So if we have provided this minimum speed, then it will make a full circle, right? So this we know. And yeah, let us do some question on that. Okay, so there are three or four questions which are dependent on this. So one. This one we don't need to just write, but this you can directly take. Right? What is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop? Right? So that you guys are that would be this. Right, guys? Right, everyone?
Yes, yes, sir.
Yeah. Then let us do another question. This is also depending on that. Yeah, these four questions are. But before we do question, okay, so this is the question. A point mass m is so a point mass m is moved in a vertical circle of radius r with the help of a string. The velocity of the mass is root 7 gr at the lowest point. So now you guys can, without doing any calculation, you guys can directly tell that will this complete a circle?
Yes, sir.
Yeah, so this will complete a circle. So we can use the idea of circular motion, right? We can use the idea of circular motion. So what do we have? We have we have this particle, right? And what do we know? That tension is applying in this side. We have also centripetal acceleration towards this center and mg downwards, right? And what we need to calculate? We have to calculate what is the tension. So T we have to calculate, right, guys? Now, now we have to apply the free body diagram. So what would be free body diagram, guys? Tell me, what would be free body diagram that we have done extensively? Just a question. What would be free body diagram? So F net that would be T minus mg, right? Right?
Yes, sir.
And then we know that this F net is due to this centripetal acceleration. So that is mv square by this one they have written as small r. So we will use small r, and this is T minus mg. So tension would be how much? Tension would be this goes over there. So mg plus mv square by r. So mg and v they have v they have told it to be 7 gr. So v square would be 7 g ohms. This is yeah, this is small r, right? R r and 7 gr divided by r. This will cancel, so we have mg plus 7 mg. So this is 8 mg. That is the tension. Is this clear, guys? Any doubt that you have? Yes?
No, sir.
No, sir.
Good. So please note it down and then we'll do another question.
Done, sir.
Done. What about you, Siddhika?
No,
Done?
sir.
Oh, you are noting.
Done, sir.
Yes. Now the next question is about tension, right? We can see that question says, so a mass M is attached to a thin wire and whirled in a vertical circle. The wire is most likely to break, right? What can break the uh, wire, right? Thin wire. Okay, so what can break the wire? That we'll understand. So a mass M is attached to a thin wire and whirled around a vertical circle, and the wire is most likely to break when the wire is horizontal at lowest point, inclined at angle of 60 degree with vertical. The mass is at highest point, right? So we have this vertical circle and this mass is rotating, right? It is here, it is here, it is here, it is here, right? So what can break the wire? So this wire is experiencing some force in this direction, and then it is experiencing this force in this direction. So mg and this mg is fixed. Mg will always be fixed. Only this tension is changing, guys. Right? Only this tension is changing. So mg will always pull it with same force, but this tension is changing. So this tension will break the wire, and wherever the tension is maximum, that is the most likely point at which the wire will break. Right? This is clear. Is this
Yes, sir.
yeah? So then we have to find out that at which point tension is maximum. So we can look at this point, right? From here we can look what were the six equations that we had, right? So you saw that the tension was minimum at this point, right? Tension was zero at this point. So this will not break the wire. Most likely this will not break. And we have two tension, this one and this one, right? The 60-degree one is in the middle. So we have to find out A or B, which one is greater. So to find that out, where is the here? So tension B is depending upon VB. Tension A, tension A is VA plus mg. So which tension is greater, guys? Which one is greater? A1 or B1? Which tension is greater? Because you know that VA is greater than VB, right? VA is larger. So let's say that I will write this part and then omit this part. So TA, if I take this thing in the other side, plus this mv square by r. And we know that mv square, that is, let's say 5 square. And then we have a tb, which is simply bb is 3 square. So which one is greater, guys? TA or TB? Which one is greater? Yes. Which one is bigger?
TA.
TA, right? Absolutely right. So from here we can tell that tension is maximum at the lowest point, right? So then we can directly say that the mass is at the lowest point, right? When the mass is at lowest point, then tension is maximum at lowest point, right? So that is the point, most likely that it will be. And we can also understand this thing in a different manner, right? So we know that TA is mg plus mva square by r. Tc is 0. Tb is simply mv square by r. So this one is larger, that is why this is the right. So please note it down if you have understood this part, and then we'll do the next question. So in this, in the book, they have written it like this, right? So they have lit this angle, right? So at this point, this is mg, this is theta, so this would be mg cos theta, this would be mg sin theta. So then they have then this is the tension, right? And this is the centripetal force. So this centripetal force, and Fc is T minus mg cos theta. So T is mg cos theta plus Fc, right? So they have so theta is maximum at 0 degree, right? So this theta is maximum because at 0 degree, this would be 1, right? At theta equal to 0 degree, cos theta is 1. So this is maximum at 0 degree. So from here, we can also see that this would be maximum at lowest point, right? And when we increase this, so at 90, this would be 0. At 180, this would be minus. So tension is maximum at this. So we can understand this in this way also, right? So whatever way you guys are comfortable with, you can use that approach. Is this clear, guys?
Yes, sir.
Yeah, please note it down, and then we'll move on to the next question. Yeah.
That's it.
Done. Okay, Rishta, what about noted?
Yes, sir.
Okay, so now let us do last question on vertical circle, and then we'll move on to bar. This one is the last question. So a body initially at rest and sliding along a frictionless track from a height h just completes a vertical circle of diameter AB equal to d. The height h is equal to how much? So that is what we have to figure out, right? So what do we know? Right. Complete the vertical circle. Complete the vertical circle. What should be the speed at this point? What should be the speed at this point, guys? That should be root 5 gr.
Yes, sir.
Yeah. So that we right. That we and this is sliding and reaching here. So in here, what energy is at this point? What is the energy that we have at this point? We have put this thing at certain height. So only potential energy is there, right? And this potential energy, when it is rolling and it is reaching here, so this potential energy has been converted to kinetic energy,
Kinetic energy.
right? So then what we will write from energy conservation, right? From energy conservation, what we can write mgh, that is equal to half mv square. Right? So this will cancel, and v square is root g, right? This is the velocity at a point. So this is the velocity at a point. And to complete the vertical circle, as Rishita has told us, so to have a vertical circle, right? VA should be root 5 GR. R is how much? This is the circle, right? This is the circle. Its diameter is D. This thing is D. So R would be D by 2, right, guys? Right.
Yes, sir.
So we will write this as 5G D by 2. This is now this is the velocity at a point, and that should be this one. So from 1 and 2, right? What we can say. So VA square is 5GD by 2. So VA square is 5GD by 2, right? From 1 and what we can see. Uh, why did I write GH, right? So VA square is simply GH, right? PA would be root 2GH. So this is 2GH, that is equal to 5GT by 2. So then G and G will cancel, and H would be how much? That would be 5D by 2. Is this thing clear, guys?
Yes, sir.
Yeah, then please do that. Yeah, whenever you guys have noted it down, please
Done, sir.
yeah. Nishita, what about you?
Done, sir.
Good. Now, uh, now let us understand about power, right? You guys already know that power is rate of doing work, right? So for small work done, this is dw by dt, and for the continuous work done, that is simply w by t, right? So these are the power. This is instantaneous power. This is power, and then we have average power also. This is delta W by delta. And we know that what is small work done, right? Small work done is F dot TS, right? This is the small work. So dW by dt would be how much? This is dW by dt, so this will be F ds by dt. So ds by dt is how much? That is FV, right? In dot product form, what we can write? We can write power as F dot, right, where V is velocity. This is how we can we can write power. So power is related with work done, right? And from force and velocity, that is how we can calculate power, right? So yeah,
Yes, sir.
this is the thing that is there for power, and we can do some calculation. This this calculate the simple one. What power would be developed by the force at the time, right? You have to calculate the power. What power would be by the force at the time? Body of mass, what kg begins to time velocity is right. Let us find it. Well, a body of mass 1 kg begins to move under the action of a time dependent, right? Well, uh, okay, so a body of mass 1 kg begins to move under the action of a time dependent force. Along x and y axis, what power will be developed by the force at the time t? So we have to find out, right, what here is of mass 1 kg. What is this force is given. This is 2ti plus 3t square j hat. And mass is also given, which is 1 kg, right? So then using this thing, what we can calculate. So we know that F is ma, right? So we can calculate the acceleration. We can calculate the acceleration at time t. So what is the acceleration, right? F is ti plus 3t square j, and that is ma. So m would be a would be how much? This is 1 kg. So a would be simply 2ti plus 3t square j. So this would be acceleration, right? And we know that acceleration is what? This is dv by dt. So dv by dt would be how much? That is 2ti plus 3t square and g. So then what we can calculate, guys? Yeah, this one is a tough one. What we can calculate, guys?
Acceleration.
Acceleration is, we have calculated acceleration, right? To calculate the power, right? To calculate the power, what do we require? We require force, we require velocity, right? These are the two things that we require. Force is already given, that is already there. So we require the velocity, right? From acceleration, we know that this is dv by dt. So from here, can we calculate the velocity? Yes, from here, can we calculate the velocity, guys? Yeah, this one is the difficult one, but can we calculate the velocity from here?
Yes, sir.
Yeah, so how can we calculate? This is a dv, this is 2ti plus 3t square j dt. Now to calculate we integrate in both the sides, right? So v would be, dv integration is v, and this would be how much? This is 2t square by 2i plus 3t cube by 3j hat. So 2, 2 will cancel, 3, 3 will cancel, and this is t square I hat plus t cube j hat. So now we have calculated the velocity as well, right? So velocity we know the force, then we can calculate the power. So power is simply F dot V, and we know that this is a dot product, so this is a scalar quantity, right? So this is F is how much? F is 2t plus 3t square, right? So I plus 3t square j dot square I plus t cube j. So how much would be this quantity? You guys tell. What is the dot product of these two things? How much is the dot product? In dot product, what are the dot products that survive? What does not? In dot product, what are the things?
Uh, the I cap, J cap, and K cap don't exist. Just the
Yeah. So
product.
only, yeah. So only I dot I will survive. J dot J will survive. K dot K will survive. So this is the This will survive. I dot j is 0. And then we have j dot I, that is 0. And then j dot j, so that is 3t square and tq. So this is 2t cube plus 3t5. So that is the power. Is this thing clear, guys? So where is the answer? Yeah, 2t cube plus 3t5. This is the answer. Is this thing clear, guys? Please tell me if you guys have any doubt, right? Yes?
Yes, sir.
Clear. Okay, so please note it down, guys. Note it down. And then, yeah, this topic is over. So in next class, we'll talk about collision and yeah, then this chapter.